quick synopsis of three typical applications of quadratic functions. Okay, fencing along a river where you've got a certain amount of fence, like 2,000 feet. You want to know how much fence to build. You don't have to fence the river. Animals have no reason to go in the river. They don't like sharks. Either that or they're afraid of sharks or they just don't like the taste of them. I don't know. Okay, so you assume that you're going to use X amount of fence for each of the sides, so leaving you 2,000 minus 2x for the length. And you've only got to fence these three sides. So what's the area going to be? It's going to be this. That's going to be 2,000 minus 2x multiplied by x, length times width, giving you this quadratic function, which you then can see is going to have a graph that is concave down because of the negative sign here. You just find its vertex. Okay. More about it in the longer version. Okay. A demand function, if you're charging price P, let X be the number you demand. Okay, so X is the demand, and it's 5,000 minus 2P, meaning that if P is the price you charge, you're going to sell 5,000 minus 2P. So if you're charging $100 a piece, you're going to sell 5,000 minus 2 times 100. You're going to sell 4,800. If you're charging $1,000 a piece, well, you're going to sell 3,000 of them, okay? You want to determine the price that maximizes your profit ultimately. The cost of making P of these things is 2,000 plus 0.75P. 2,000 to set up, 0.75P to manufacture each, 0.75, like 75 cents to manufacture each one. Your revenue is going to be the number you sell times the price. That'll be X, number you sell, times price, which is going to be this. You want profit, you're going to have to subtract the revenue. So you have, I'm saying you're going to have to subtract the cost from the revenue. So the cost minus the revenue, clearly here. Here's the cost, here's the revenue. And I'm saying the wrong words. Here's the cost. No, back up. Here's the revenue, okay, and here's the cost. Okay, so you're going to subtract the cost from the revenue to find out how much profit you make. Okay, this is clearly a quadratic function, needs to be simplified a little bit. And once you simplify it, you have a quadratic function, and you think of finding the vertex. It's got a negative concavity, just like this one does, and the analysis is going to end up very similar. You have a projectile path. Typical ideal projectile path is a parabola, so it has the shape. Physics tells us that, and we observe it, measure it, and everything, and we find it's true. Okay, so you let y equal ax squared plus bx plus c for some value of a, some value of b, some value of c. Depends on how fast and at what angle you fire the projectile, and what units you're measuring in. Okay, so you want to find the maximum height and you want to find where it lands. Well, let's assume that the y-axis is here and the ground level is at y equals 0. Well, finding the maximum height is going to be easy whatever the ground level is. So we just maximize the function using the same techniques we always use. Where does it land? Well, if the ground is at y equals 0, it's going to land when y is 0. Which means that if y is 0, we have the equation ax squared plus bx plus c equals 0. We solve that and we figure where it lands. Now we want to be careful, we're going to get two results, one here and one back here where the projectile never was. So you got to be sure you choose the right one that fits the conditions of the problem.